this is something where all you have to do is set it up. I don't want to find the answer at all, but notice we have 3 different sections. 1, let's see if I can do this color-wise, 2 and 3. Each one of them has a different top and bottom and a different barricade for the X's, right? It's partitioned differently. So what I want to do is I want to just mention the area. So let's start with this area in the blue. Where is it partitioned? Well, we have the X value at -4, and then the intersection point conveniently at -2. If it wasn't so convenient, then I would have to use my calculator and graph these two and find the intersection point. That's what Delta Math had you do. And then notice we have a top function, and we have the bottom. And there you have to follow the curve. So here's my top for section 1. And I have the integral from -4 to 2 of 0.5 x squared. So top minus, what's the bottom? The bottom is the linear equation. Notice there's 2 pieces to that. So you do have to put parentheses. If you did not put parentheses, around that, you would not get that correct. Okay, that's very key. Now, I don't have this laid out, but I should do, right after it, I'll add the next section, which now, section 2 starts at -2, and it goes to the intersection point of 1. So there's my lower bound, my upper bound. But notice the top and bottom flip.
The upper bound is the first one to the -2.
Oh, thank you. Good catch. Good catch, yeah. Little things like that, right? That's why they pay you guys to be here to catch my errors, right? But notice your top and bottom switch. So now the linear portion is the top, so that has to be the first one. You technically don't have to put this in parentheses because we're subtracting the second one, but to be honest, it doesn't hurt if you do. And then when we do the, is that better? I'm going to blame it on my glasses that are fogging up. It's definitely not the case. But top function is linear, bottom one is now the quadratic. And then you do have to write dx. So check your notation. Did you start with the integral? Are your bounds correct? Dx has to end each one. And then we're going to add the final piece. Let's see if I can do this one right. We're going to start at 1. We're going to end at 2. And then the top, now it's different. 0.5 x squared. And then we're going to subtract the bottom, which is the linear. There we go. And there it is. Any other errors? No. Let's see. Does that look good? I think so. Okay. Now, what if you actually were to ask to evaluate this, but you're allowed to use your calculator? Which you probably would, because this would be a nightmare to do. What do you need to show? You need to show all of this, and I hope everybody sees that right now. Right? If you don't show this, and you just write your answer, you might get a point, or they might say, we don't know where that came from, you might get 0 points. So the bulk of the AP test is showing the setup for the answer. It's showing the calculus. All right. I know you've seen this one before. Here's my quote for today. Sine green, cosine, or so cosine green is tan. Yep. Oh, hey, I did put it. Okay. I want you to think about this. What if I give you this graph and I say I want you to find the area between the curves, but now we have a horizontal line that divides it by y equals c and y equals b, and then our functions, which I didn't put them in here, but this could be function f and g. What do you think you could do to approach finding the area of this function? Can we take the approach we did in the warm-up, roughly? Watch what happens if I try to focus on these x values. Right? So what if I took this spot here and I went straight down? That doesn't give me a clear partition. And same thing here. If I took this spot, it doesn't break it down nicely. So in this case, the x, oh no, thought I grouped those together. In this case, the x values aren't of really any value to us. So what we're doing today is we're basically going to switch our view. Instead of looking at everything with respect to the x value, what if we look at in terms of the y? Right? So now I shift my thinking. I have a clear partition here and a clear partition here that groups this part of the area nicely. And now I don't have a top function or a bottom function. What do I have? I have the left and the right. Now, we want to think of which one is greater. If I'm thinking of left and right, which one is greater, f or g? G. Okay? So, we have the right function here, and then we have the left function here. And what we're going to do today is we're going to switch our view to the y-axis. So the integral from, not from x to y, but from the lowest y, not from x to x, but from y to y. We're going to go with the lowest value, which is c, to the highest value, which is b. Now we're going to take the right side, and we're going to subtract the left. Now this is tricky. What do you think is going to be written right here? dy. Perfect. dy. Everything now is written in terms of y. And one of the biggest things you need to know, it'll come into play in a little bit. Look at the y values. The equations here are in terms of y. So we're going to have to write those items in terms of y. Now, you don't have to write that. And this, I just want a quick mention. This is kind of the theory behind it. But don't write this down. There's something called the horizontal line test. We knew the vertical line test told us if a function existed. Well, if you have a set of points in the xy plane, and the graph of the function is the form of x equals f of y, so they basically switched to the x and y. They solved for x here. And then this is true if and only if every horizontal line intersects the graph at most at one point. So see how this horizontal line intersects this graph at one point? And this graph at one point, which means we can use this option to find the area under the curve. That's all theory. You're going to be able to tell visually that it works. So if that's the case, what do? We set up the same integral, except for now, it's the most right function minus the left function with respect to y. Okay? I don't think you need to write that because on our first example, I'm going to rewrite what we have right here. Okay? And here it is. So officially, we are finding the area between curves with respect to the y-axis now. So we're going to use y and dy. Do a very rough sketch. You don't even need to have grid lines here. I'll give you the location of these points. But this one I'm going to kind of set up more as like a step-by-step, just so you guys can kind of see the full process. So let's take a look at, first, one of the harder things that's going to happen today is determining why am I using the y values, the horizontal test, versus the vertical test. So let's look at this as if we didn't know about the y values right now, and I tried to do it using what we learned yesterday. Well, I have an intersection point, and I have an intersection point here. And if I was to find the area here, don't write this, by the way. This doesn't perfectly define this area exactly. I'm not saying we couldn't use creative measures to find this, because you could find the area of this blank space and subtract it. So there is one way to do that. However, it's just not perfectly set up to solve this as quickly as we could. What if I focus on the y values? So look at this line right here. This is the equation at y equals 0. And then this is the spot at y equals, well, actually, is that 2 or is it not? I'm not sure, because my graph isn't fully numbered. I guess it is. But what if we don't know what that is? How can we find the intersection point? And how do we find that without a calculator? Well, what has to be true is the two equations have to be equal. Right? So this is side work, but I'm going to try to find the intersection point right here by taking the two equations and setting them equal to each other. Now, this might require a little more work than I might have room for, but we got to square both sides. Ooh. I don't like the way I put that. I'm not going to have enough room. I'm going to go down here. Sorry. I'll say point because there might be more than one point that's present. But when you set the two equations equal to each other, because they're both equal to y, so you set them equal to each other, then we're going to solve. So if I square both sides, I get x on this side. But then I have to FOIL this out, and I get x squared minus 4x plus 4. And then I have to subtract the x. And then hopefully we can factor, which I believe this one works out okay. Factor is positive 4 that add up to negative 3.
Negative 5. No minus 5.
I have no excuses today. I'm happier that that works because now we're able to factor that. There we go. And then set each one equal to its own 0. And again, our goal is to get these two values without showing a ton of work. Right? But that just tells me the values of x. It doesn't tell me the y value. So then I got to go back to one of them, which was, let's take this one. Now what happens if I plug in 4? Y value is 2. Right? And that's the spot that I need to find The other spot, which I don't really care about right now, is when y is 1. So I have two intersection spots at 1, 1 and 2, 4, 2. But that's the spot that I'm looking for. Alright, so that just confirms, and yes, I know you can read the graph, but there are going to be times where you're not given a graph, and you just set the equations equal to each other, and you can still find the intersection points without even graphing. So this is the spot over 4 up 2, which tells me this blue line is the line y equals 2. And that helps me divide this up. Okay, so first, this might have been the first thing we should have done in terms of our steps. Find the intersection points. But I have a small problem. My equations are written with x in them. I need to have both equations rewritten so then we are written in terms of y, which means we just need to solve for x, which we kind of can do in our head, right? If I add 2 over here, I'll get a y plus 2, and I'm just going to call that x equals. And then the other one, we're just going to square both sides, so I'll get a y squared and x equals. So now the equations are written in terms of y, which kind of has that horizontal thinking. So the next thing we need to do is set up the integral with respect to x and y. So the bounds are going to be the lower y value to the upper y value. We'll go from 0 to 2. And we always take the right minus the left. So when we change our thinking to the horizontal y's, now it's which one is the furthest to the right. Here's where you have to be careful. It's a linear equation, but I'm not going to write x minus 2. I'm going to take the term written in with respect to y. And then which one is the furthest to the left? That's the one that's completely farthest to the left. So that would be y equals square root of x. But we want to write that in terms of y. Just for fun, I would always put parentheses around there so you don't ever forget it. And dy. It takes a little bit of training just to change your thinking to get all these pieces kind of right. But then it's the same thing we did yesterday. Now, we're going to evaluate this by hand, the same way we did. So why don't you guys go ahead, find the antiderivatives, plug in 0, plug in 2. I'll show you how to do this on your calculator then afterwards.
Wait, so the first thing, you did the y equals x equals y plus 2?
Here?
Yeah, you do that first, right?
Yeah.
Do that first.
Yeah. You have to do it before you plug it in here and here. Now notice, what would be a problem, or would you notice the problem, if I accidentally wrote x minus 2 here? You see how that conflicts because there's a y. Everything, because we're saying dy, everything has to be written in terms of y. So the functions and the bounds are all the y values. All right, but once you're set up, now take the antiderivatives and just work through this. So I like to rewrite it so this minus y squared is coming first, and that way things are in order, but you definitely could just work from the original. So I'll take the antiderivative, which means I'm going to add 1 up top, so I have to put a divide by 3 or a 1/3 up front. Then I'll have a y squared, so it's a 1/2, and then I've got 2y. And then we still haven't done anything with the bounds. So we're going to evaluate from 0 to 2. Now here's something you can do to save yourself time. You know, because if you plug in 0, if I put in 0 here, here, and here, it's going to equal 0. You don't have to show that work if you're confident that it's 0. Now, if I had a sign value or e to the x, that might not produce a 0. So that's the only time I'd say be cautious. But this is just a polynomial. So that saves me a little bit of time. And then we can just simplify. 2 to the third power is 8. 8 times negative 1/3 is negative 8/3. 4 times 1/2 is 2. Now, if this is going to be, if this whole thing is 2, I think it's better to think of 2 as 6/3, because then I have my fractions ready to be combined. And I know I've got 4 here, but it might be better to think of 4 as 12/3. Now everything has thirds. Negative 8 plus 6 is negative 2. Negative 2 plus 12 is positive 10/3. So, how do we do this in our calculator? All right, how would I take this part right here and plug it in? The nice thing is, the exact same way you do it as if it's x's. Because we don't have a button for y to plug into our calculator, so just grab your calculator, do math 9, and enter it in instead of y's, just put x's, the same way we did yesterday, and see if you get the same answer. If not, that means we probably made an error somewhere on our page, which, going off of today, is pretty likely. Enjoy the luxuries. Okay. So hopefully you guys got the same thing. You might have got 4.333 repeating. Is that right? Was it 4.3 repeating? 3 point? Oh, sorry. 3. Yeah, that makes more sense. 3.333 repeating. So if not, double check that you entered everything incorrectly.
So why are the bounds?
I don't think you need to. It might take a while. I just want to show it to you, and we can check that in a second. So look at the directions here. It says find the area of A on the region bounded by the graphs of y equals and y equals. So they give us two equations that are very close to being the same. This would be a no. This could be a no calculator question, and this is where it gets a little challenging. Do you remember what the graphs of the square roots look like? That's the part where hopefully this would be a calculator question, but if it's not, here's kind of how I would recommend thinking of this. You might not remember exactly what this looks like, but what if I solve it? What if I solve for x? What if I square this side? I'll do some side work here. So what if I square this side, and then I move the 4 over? So subtraction. And then I divide by negative 4. Okay. Does that help you at all? Maybe, maybe not. But I'm thinking, wait a minute, squared, that's a parabola. It's the y value. It's this way. And then it's got a negative 1/4, so instead of reflecting down, it's going to reflect backwards. And then it's going to shift 1 unit back. I'm not sure if you are super comfortable with that, but again, we don't need an awesome graph here. I just need a quick little understanding. If I have y squared, instead of the parabola opening up this way, a y squared would open that way. It's kind of a reflection. And then the 1/4 and the negative, we're going to open it up just in a different direction. I'm not really super concerned about the 1/4 getting narrower. Again, we just need a visualization here. And then what about this graph? Okay. I want to solve this one. So what would happen here is I would square it. This is what I would do. I would move the x over to this side, and then I would bring the y squared over to this side. However you do it. Now I get a parabola that's opening backwards, but it's going to be shifted 4 units to the right. 1, 2, 3, 4. Now, the other thing we have to be really careful with is the fact that this is only a positive answer. Remember, if it was squared and we took the square root, we get a positive and negative, which means we're only taking the values above. So we're bounded here, and then they would intersect at some point. When we do that, here's the nice thing. I'm not going to really give you something that's too crazy, and if you see a graph that you're not sure of yet, use Desmos. If you just type in Desmos.com, graphing calculator, and what did I have there? You could enter in this equation, or you can enter it in terms of y as well. So I'm going to memorize these. Negative 1/4 y squared minus 1. Equals x. And there's part of your graph. And then the other one was negative y squared plus 4. So negative y squared plus 4 equals x. And you can see this is definitely a much better piece. And look at how quick and friendly it gives you the intersection points. You don't have to do any extra searching. Now we know we're bounded by the x-axis as well, so we're going to look for the area in this spot right here. All right. So that's just kind of how you can get graphs. You can see my graph definitely wasn't accurate enough. But I will mention you can't always trust the intersection points on Desmos. So just be careful on that. What would be best here is to do what we did before. If we set these two equations equal to each other and we find the intersection points.
How do we know which one's the right intersection? Because on the Desmos it shows like -6 on the x-axis.
Yep. So there's one down below too, right? And what we have here is we have the two functions that are positive, so we have to take only the positive pieces and bounded by the x-axis. So this is the area that we need. So then I only need the intersection points here, here, and here. Okay. So what could I do? I could set these two equations equal to each other. And then my goal is to solve. The nice thing is they both have square roots. So if I square both sides, it's just a linear model. If I add the 4x over here, I get 5x. Nope, I get 3x. And then if I subtract the 4 over here, I get 0. So I basically get 3x equals 0 or x equals 0. Well, what if I plug 0 in right here? That leaves just 4. Square root of 4 is 2. So I get the x is 0, and y is 2. So I get that intersection point really nicely. I really don't have to find this intersection point, these here, because they tell me that I'm separated by the x-axis, which is y equals 0. So that's all a little side work piece that you just have to be aware of. They expect that that's something from Algebra 1, 2 that you guys are really good at. We're not going to do the x-axis one. We're just going to look at the y-axis. So we're shifting our thinking. If I'm going to do the bounds here for the y-axis, what's the lowest y value that I have here?
0.
0. Right, perfect. I'm going to go from 0. Now what's the highest y value that I reach? 2. Okay. And then we're going to subtract. Instead of the upper minus the lower, or top minus bottom, it's right minus left. So what is the rightmost function? That's the one where it gets a little harder, right? I didn't label it on my graph, so which one is this? This is where I think it's important to look at the plus 4. So the most right function is the y value, and I do have to have this written in terms of y. And then the leftmost function is the shorter parabola, but that is the one that has the -1 plus. Oh, this should be a +1. Because I divided by a negative. Of course, I made an error. That's why we're at a +1. Four y squared plus 1. And then okay. So what was the takeaway? And again, I think once you get this set up, I'm hoping that the antiderivative piece is fun. You can do it in your calculator or you can do it by hand. It's nothing tricky. So I'm not going to go further than that. This is just setting it up. But we could ask you to go further if you needed. The big thing here is, what do we do if we're not given a graph? You can sketch one, or if you realize which value is further to the right, you really don't need a graph if you understand kind of how these functions work. Like knowing that this had a +4, so it's going to be further to the right. This one had a +1, so it's not as far. And then finding the intersection points, which I erased, you could do that with your bounds. I'm a visual learner, so I need the graph to help me out. Okay. Let me see. This is our last one, but we've got, it'll work. I do want you to write this one down. And let's do this. I want you to just draw a sketch. Notice it says calculator problem. So if we tell you it's a calculator problem, I really just need to see the integral that you set up and your answer. And that's it. Now this is something that they do give us some restrictions here, so we have to be very conscious of what everything means and how and why it's written. So find the area between the curves f and g, but notice how it's not f of x, it's f of y, and it's g of y. That's really friendly, or that's a sign that tells you everything's written in terms of y right now. So I'm going to shift my thinking, instead of vertically, let's think horizontally. We're going to think of it in terms of the y values. And then just for a quick sketch, here's your graph. So this is interesting. This telling you that you're focusing on the region from negative pi over 4 to pi over 4. Those are my bounds. Right? And notice it's written in terms of y. So you automatically know how low you're going to go and how high you're going to go. But on the graph, here's what it looks like. This is the equation y equals pi over 4. Here's y equals negative pi over 4. So the only question now is, which one is the furthest right and which one's the left? Well, you could use a calculator, but true. But that's a lot of work to solve this, right? Because we can't put y's in our calculator. Even though if I graphed it, you could still kind of think of it. Here's what I would do. They give us this point. When x is 1, y is 0. Let's plug it in. Or maybe this one's even better. 0, 0. When x is 0, when does y produce 1? So if I have a y value of 0, cosine of 0, what is cosine of 0? 1. And then 1 squared is 1. So when y plugs in, my output, which is the x value now, has to be 1. So that means that this cosine value is the green. So I would label this as f of y. And then g of y, if I plug in 0 here, the sine of 0 is 0, and 0 squared is 0. So you can test the points that are given to determine which one is your left one and which one's your right. So my farthest right is the f value of cosine, and my farthest left is the sine squared dy. And that's the only work you need to show. Now, when you grab your calculator...
Wait, is it supposed to be dx or dy?
Good catch. Another error. Man, I'll tell you what, if this was like the major leagues, I'd be cut middle of the game. Thank you. Good catch. I also completely forgot Zoom was on and you scared the heck out of me.
Sorry.
No, that's good. Keeps me awake. So how do we type in cosine squared, right? In your calculator, you actually have to put parentheses and write it this way. And your calculator is really finicky. Some of you might have to put an extra parentheses around the y, and then the squared is on the outside. Okay? You might be able to get away with having the black parentheses and putting the squared on the outside. That could work as well. So I think you could write it like this instead. But go ahead and try that, see what you get. Oh, is it done? Yeah. You could just hit the number line too. Right? Just have a whole lot easier. And remember, we cannot use the variable y. So when you're typing this in your calculator, you just have to use it as x, and it'll give you the same answer. I'll model this one on my calculator just in case you have questions. And you should also check that if we don't get the same answer, but everything's typed in correct, there's a chance you could be in degrees mode instead of radians. Sure. What'd you get? You got 1? That's a good thing. All right, let me show you what I did. So my calculator is nice enough where I don't have to put cosine in parentheses. I can just put the x. I think the TI-83s you have to put the cosine, but I'm not positive on that. So that's what it looks like. I already checked to see that I was in radian mode, and we should get 1. Okay, so notice how our calculator, we can only use x variable, we can't put y in here. So even though you do have the ability to find the letter y, I haven't tested that, but I don't think it's going to treat that as a variable. So you should use the x variable. Now, since we have time, do we have time? Yeah. What happens if I accidentally flip the left and the right? What do you think is going to happen? Try it. See what you get. Rewrite this exactly the way, but do sine first and then cosine second. What did you get? You got a -1. You know why? Instead of calculating it from left to right in the positive direction, you went right to left, which is the opposite direction. So you're going to get the opposite area. So one of the things you could do, and I'm not going to do this I don't want you to do it too much, but this is a good example. To combat that, what if I take this exact same example and now I do the absolute value. Okay, so what if I put the absolute value in there, and then I do the exact same thing that I just did? Actually, I'm going to do sine squared. So what if I accidentally flip it around? Because we're calculating area between two curves will always be positive. If I was to throw my calculator with the absolute value, so notice the only thing I did was add in the absolute values around everything. It just turned that positive. So here's what I would say for you guys. Let's say that you're doing your work, and maybe it's a no calculator problem, and you get your answer to be negative. So we know that's our answer, but let's say you accidentally did this. And if I asked you to do this all by hand, and you did all that work, and you got a negative answer, you got a -1, here's what you can do. In your work, put absolute value bars around it, and then take your answer and put absolute value bars around that, and say it's 1. Area will always be positive when it's between two curves. We have to make sure we understand that. When it's between two curves, it's just how much space is it taking up. Right? Any negative, yep. So, and what that means is you probably just flipped the left and right around, but if you did all this work by hand, you don't want to go redo it, right? So correct it by putting absolute value bars.
So why don't we just put the absolute value bar around the big components?
If I just put it right here and I don't do this, this is mathematically untrue. Right? Because you can't just say, oh, I want to make this positive. It has to have reason or meaning, right? So what has to be true is the integral that you set up always has to reflect your answer. If you were to set up the wrong integral and then just put the answer down here, they're not going to give you any credit because there's no true connection. All right, so this afternoon, students on Zoom, you can use the office hour link, and at, let's see, 12:55, we're going to do a practice free response question. We've got one question here laid out. I'm going to give it to people in class. We're going to do about 15 minutes of work time, and then at the end of that time, we're going to go over the free response in class, and that's going to be one of the very first times that you guys get a chance to try it, grade it, and get some feedback. So those of you who are on Zoom, you are welcome to come back. Make a note, 12:55, and use the office hour link in my Schoology, on the Schoology page. The homework tonight is 2, 4, 6, 7 questions. Some of them have graphs, so it's really nice. If the graph is on the textbook, you don't have to draw the graph. You don't have to do any calculator work to find the intersection points. You can just trust the graph. Okay? If there isn't a graph, then I would recommend using Desmos to produce one, just to get you to be helped out. One last thing I do want to mention is, what if they gave me an equation that looked like this? Which I forgot to add an example in there. So they're saying that here's one of your equations, and maybe here's the other one. So if I say create a graph with these two equations, here's my hint. Notice how that one's already in terms of y. So we're going to use dy dx. You need to just take this one and solve for x. So you might have to do a little bit of algebra first. So that equation now is written in the form of the other one. Does that make sense? Okay. And if I asked you to do this with respect to the x-axis, then you would solve this one in terms of x, and you would solve this one in terms of x. You basically subtract the 4 over. So you can algebraically manipulate the equations that are given to meet the needs of whatever the question is asking. All right, that's what we got. Adios on Zoom. Have a great day.
What is the FRQ question about?
What is it about? It's going to be a review of, there's some integral stuff. I tried to make it connect to what we're currently doing. However, we just started this Unit 8. So all the free response questions from Unit 8, we could do one part of it right now. We haven't learned everything on that. So it's another connection to integrals, which we've been doing.
Did you just say before it was like practice for the MCA?
Oh, I can show you guys what you want to do. If you guys, I'll email you a link. So if you want to practice for the MCA, you could do that this weekend, and I'll just give you an extra little website to look at. Yep.